This video is on lesson 5.2 in our textbook called Using Letters as Numbers. It starts on page 224. First thing we're going to do is learn how to write an expression if we're given a problem. If I tell you Ms.Kayal is now 26 years old, what's her age going to be 1 year from now? Write an expression. Ultimately, the goal of writing the expression is to find the answer, but when I tell you to write an expression, you should not right away say 27. You should write the equation. An expression is pretty much an equation. What's your mathematical equation? So you should be writing 26 plus 1 in order to find my age a year from now. And then you can say equals 27. If I ask you, what was Ms.Kayal's age 2 years ago? You should take my current age, 26, and think about how are you going to find out how old I was 2 years ago? Your operation is going to change. Now you're talking subtraction. You're going to go back 2 years, and your expression looks like this, 26 minus 2, which will give you 24. In algebra, we are often given a problem where we don't know the value of the number. So for example, we could have a 5th grade teacher and we don't know his age, but then the question asks you write an expression for his age a year from now. How are you going to represent the teacher's age a year from now if you don't know their age right now? Well, you can use a letter to represent that number that you don't know. So the unknown number, you could use a letter for it, and that letter is called a variable. A variable can take on different values. So for example, we could use X as a variable, or we could use Y, or any letter in the alphabet. It's called a variable because the number it represents can vary. So X can mean different numbers in different problems. It does not always equal 3, for example. It does not always equal 5. So when you have different algebraic expressions, X can represent different numbers. So I don't know this 5th grade teacher's age right now, Mr. Haskin, but I want to know his age a year from now. What should your expression be? The only question we're asking here, write an expression for Mr. Haskin's age 1 year from now. You would take his unknown age, which is X in this case. We assigned a variable to the number that we don't know what it is. You'll take your X and you'll add 1. X plus 1. This is my expression to represent Mr. Haskin's age a year from now. This is my algebraic expression. An algebraic expression is an expression that contains at least one variable. My variable here is X. When I ask you what's the variable, you're going to tell me X or Y or whatever letter is being used in that expression to represent the unknown number. If I ask you what was Mr. Haskin's age 5 years ago, what expression are you going to write? Your expression should look like this. You should still represent Mr. Haskin's age as X. And then, if I ask you what was his age 5 years ago, your expression should be X minus 5. Now you're subtracting because you're going back. So in this case, X plus 1 and X minus 5 represent algebraic expressions. You will have some questions that simply ask you to write an algebraic expression, and you will have some questions that once you write the algebraic expression, they will give you a value for X and they will ask you to calculate. If I tell you, if Mr. Haskin is 47 years old, then X equals 47. And now you can calculate how much he's going to be a year from now and how old he was 5 years ago. You can do X, which is 47 plus 1 and 47 minus 5. Sometimes algebraic expressions have more than one variable. You might see something like X plus Y. These are two variables we're working with. You could see X minus Y. You could see X minus Y minus 1. Really, the possibilities are endless. These are all forms of algebraic expressions. Sometimes a question will give you a value for X and it'll expect you to carry out the expression and find the result. Or it'll tell you what's Mr. Haskin's age in terms of X. So here all you have to do is write the expression. It does not give you a value for X. It tells you that now his age is X. 4 years from now, his age, you're supposed to write it as X plus 4. 10 years from now, you should represent his age expression as X plus 10. 5 years ago, you should represent it as x minus 5, and 8 years ago, you should represent it as x minus 8. Sometimes a variable can be used in place of a number in an algebraic expression. So, you can have a problem that tells you add 2 to 6. In that case, you would just say, you would have 6, add 2 to it. You would just have 6 plus 2. If it tells you subtract 3 from 4, you have to take your 4, subtract 3 from it, take away 3 from it. You'll have 4 minus 3. What if it tells you add x to 6? What are you going to do? What's your expression going to look like? Instead of add 2 to 6, it's telling you add x to 6. So it should be something like 6 plus x. You just add x to 6. If I tell you subtract 3 from y, be careful here. Be careful with the wording. There's a difference between subtracting y from 3 and 3 from y. When I tell you subtract 3 from y, you should start with y and take away 3 from it. If I were to tell you subtract y from 3, you would start with 3 and you would take away y from it. So be very careful with subtraction because it does not work the same way both ways. With addition, it does. If you could do 6 plus x or x plus 6, you'll get the same result. But with subtraction, you have a totally different algebraic expression and a different answer, so you need to be very careful with those wordings. Add 5 to z. What are you going to do? If I said add 5 to z, you should start with z. I have z, and then I'm going to add 5 to it. Find z less than 11. Now this is worded a little bit differently. It does not say subtract, it does not say take away. It says less than. Less than and greater than in math, we know, represents addition and subtraction. So find z less than 11. Once again here, you should start with 11 minus z. That's how your expression should be. Find z more than 9. Now we're doing more than. Find z more than 9. You should start with 9. And what's z more than 9? It's just 9 plus z. If you thought I went too fast there, I'm going to give you a few more examples. Be very careful with the wording. The way you write your expression, according to what the question is asking, is really what's important here. If I tell you add 2 to x, you should start with x and add 2 to it. If I tell you 9 less than s, you should start with s. What's 9 less than s? It's just s minus 9. Now be very careful here. Once again, subtract y from 7. Y subtracted from 7. You should start with 7 and take away y from it. This is y subtracted from 7. But 7 subtracted from y would look like this. So be very careful with the wording and just think about it logically. Think about it logically. What does the question say? What is it asking? Read it word for word and be very careful how you answer. If I tell you subtract y from 7 and you give me y minus 7, the answer is wrong. Your expression is wrong. The way it's written is incorrect and your answer would be incorrect. Sometimes you'll have an algebraic expression with a variable in it, but then you will be allowed to evaluate the value of the variable because they'll give it to you, so you'll evaluate the answer on your own. So if it says, evaluate for x plus 5 when x equals 9. If x equals 9, you would just replace it for the x, so you'll have 9 plus 5 will be your expression, and you'll find the answer to be 14. Find the value of 5 plus x when 5 plus x when x equals 23. You'll just replace the x with the 23, you'll have 5 plus 23, and you'll find that equals 28. Sometimes you'll be given a table, and the table gives you the expression on the left-hand side, and it'll give you two different values for x. And then you'll have to calculate for both of the expressions. So for example, if I give you the expression of x plus 4, calculate the answer when x equals 8 and when x equals 30. So you'll have to go and do your calculation for both of these x values. You can replace x by 8 first, so it'll be 8 plus 4, and then you'll replace x with 30, so then it'll be 30 plus 4, and you'll find your answers that way. You also need to know how to use variables to form expressions involving multiplication. If I tell you a box has 12 plums, how many plums are there going to be in 2 boxes? So one box has 12 plums. If I tell you I have 2 such boxes, your expression is going to be 12 times 2. You'll just take your 12 plums and you multiply it by 2 boxes. And then you'll find out that there's 24 plums in both boxes. What if I don't tell you how many plums are in the box, and I just represent the number of plums with the variable n? I'm going to represent this is my number of plums in the box. And I tell you how many plums are in 2 boxes. All you can really do here with the information that you have is multiply n by 2. I just tell you I have n plums in there and I have 2 boxes. How many plums do I have? All you can do is n times 2 or 2 times n. In other words, this could be written as 2n. Sometimes we write multiplication expressions in algebra with just the number times the letter right there without using the times symbol, because sometimes that can be misinterpreted for the letter x. So instead of thinking we're doing 2xn, here all we're doing is multiplying n 2 times. So we're just going to represent it as 2n. So when you see 2n, it's multiplication. It's not 2n's. And when you see 3n, if I tell you I have 3 boxes, how many plums are in 3 boxes? It's going to be the same thing. It's going to be 3 times n or n times 3, but we're going to end up representing it as 3n in order to avoid any confusion, so that we don't have 3xn. We'll just have 3n. That means we're representing plums, which is my n, in 3 boxes. It's important to note here, when we're multiplying a variable by 1, usually we would just represent the variable. We would just write n, because 1 times n is n. So sometimes if I want to tell you how many plums do I have in 1 box, you would just write n. That would be your algebraic expression here, or 1n. But 1n is n. In other words, 3n, just to recap, is the same as 3 times n, or 3 groups of n, or n times 3, or n groups of 3. This is all different ways of representing the same information, 3n. In other words, 1 times n, we learned, is the same as n times 1, or 1n, or just n. Some questions are going to ask you, write the expression in 3 other ways. It might give you the expression of 4k. Write 4k for me in 3 different ways. You could say 4 times k, k times 4, 4 groups of k, and k groups of 4. These are different ways of representing the same information. If I had a table like this that says there are n stickers in 1 package, find the number of stickers in terms of n. Then find the number of stickers for the given values of n. So if I have 1 package and the number of stickers in it is n, calculate how many stickers do I have when n equals 15 and when n equals 20. In the first case, 1 package means I have n number of stickers. When n is 15, I have 15 stickers. When n is 20, I have 20 stickers. In the second case, when we're talking about 4 packages, how are you going to represent the number of stickers in 4 packages? You should write it as 4n and calculate. How many stickers would you have in 4 packages if n equals 15? You would just do 4n. So n times 4. So 4 times 15, you'll get 60. And 4 times 20, you'll get 80. What if we had 7 packages? You would represent that as 7n. You would do 7 times 15 and 7 times 20 and get your answer. 10 packages would be represented as 10n. You would do 10 times 15 and 10 times 20 to get your answers. And 15 packages would be represented as 15 N stickers. And then again, here you would do 15 times 15 and 15 times 20 to find out how many stickers you have in all 15 packages.